To my channel. In the last couple of weeks we started looking at some important computer vision textbooks, and so today we'll be starting another one and look at the high level of what is contained in this textbook. So the textbook here is Modern Computer Vision with PyTorch. PyTorch is a framework for developing machine learning or deep learning models. So it's created by Facebook, and its competitor is TensorFlow, which is from Google. So let's quickly dive in and see what is contained in this book. So we first let's look at the first part of the book, which is the foundation part. Okay, so in this session we'll talk about the fundamentals of deep learning for computer vision, and we look at first the artificial neural network fundamentals, PyTorch fundamentals, and building a deep neural network with PyTorch. So let's look at the first part, which is artificial neural network. So the ANN is a supervised learning algorithm. Now when you talk about the deep neural network, it actually comes from the artificial neural network. When you have more layers, essentially when you have more than one hidden layers in your network, in your neural network, then we call it a deep neural network. And this algorithm is inspired by how the human brain cells activate and how it functions. So when your eyes see some certain object or certain color, there's a part of the cell brain of the brain cell that actually fires. So that's the inspiration of this particular algorithm. So essentially it's a function approximator. It takes in an input and it gives you an output, and it's able to model some high level non-linearity in your input to give you an output, as we will see. So here we talk about the universal approximation theorem, and what that theorem says is that there always exists a neural network for any kind of function. So you can approximate any function with a neural network. So you can always find a large enough neural network architecture with the right set of weight. And when you talk about weight are just numbers, some numbers that we are adjusting that can exactly predict any output for any given input, no matter what that equation or that function is. You know, a function is a black box that takes in an input and gives you an output. So whatever output you want, you can always find a function to represent that with neural network architecture. So that's what this is saying. So we keep adjoining, given a data set, we learn from the patterns of the data set and keep adjusting the architecture until keep adjusting the weight of the architecture until the neural network predicts what exactly we want to get predict. And the process of adjusting the weight is what we refer to as training a neural network. So this is a typical example of how on a big very popular data set, ImageNet, how the neural network achieved a remarkable performance in 2012, and that neural network is called AlexNet, and it beat the previous performance by a very large margin. And with more deep and complex neural networks, and the classification error kept on reducing, now up to 3.1% in 2016, which has even proved better than the human level performance. That is, humans annotated this and they got a 5.1% error rate. So lower is better. So that is it for now. In the next session, we'll look at comparing AI and traditional machine learning. Thank you for listening, and see you in the next one.